Hello guys, welcome to another episode of Xah Talk Show. We are going to code emacs lisp. I'm going to explore the emacs lisp pcase, which is pattern matching, destructure, that topic. Okay, I don't know that yet, so I'm just gonna explore and study and maybe explain part of it. So this is not a coherent lecture about emacs lisp, the programming language, but you can enjoy the ride. If you are watching this offline, skip, and play at 1.5 speed because I ramble. If you are here, say hi. Love to see your messages. Okay. Now drink coffee and tea. You see my elaborate setup. Okay, remember skip. Okay, so Glove 80 keyboard, fantastic. Ultimate hacking keyboard, fantastic. Nulia trackball, fantastic. And this fancy device, most advanced Svalboard, Svalboard. Okay, you should get it. Expensive though, so I have a video review for each one of them. I will be using Svalboard. You know, Windows is very annoying. Every time you jiggle the USB, it disconnect and reconnect, and you know that's why you hear doo-doo-doo. Okay, emacs lisp pcase. Okay, let me relax and go slowly. Remember, skip around, play at 1.5 speed. USA Army, be all you can be. Nice coffee. That's coffee with honey, elite honey from Costco. The American middle class elite, Costco. Okay, pcase. Okay, so pcase is a Lisp library introduced about maybe 10 years ago. So pcase. Okay, let's look up the documentation. No, not search Twitter. I pressed the wrong key. So pcase describe function. Pcase, there it is. So it is in this package. Okay. So the Lisp library is pcase.el in the standard Lisp bundled library. Okay. So this is the source code, about 1,000 lines of code. Okay, and it is written by this guy I respect, Stefan Monier. He is a professor researching functional programming languages, and he has been a GNU Emacs leader for about 5 or more years, starting about 2008. Okay, Stefan Monier, a professor, researcher in functional programming languages. So that's today we're gonna look into this package because this is very useful, and I'm just gonna learn how to use it, okay, and talk about stuff. That's what we're doing, okay. So so recently I changed my key binding. What is the key binding for H, wait, tab HM. I just changed my key binding today for Xah HTML mods, so I forgot. What is the pre-tag H? Okay, so H new pre-tag. What is it? Insert pre-tag. Oh, THH. Okay, emacs lisp. Okay. God, the key binding is wrong again. TH, I want to pop it out. What is it? God, Rh toggle HTML is insert. I forgot what's the command to pop it out. Okay, so tab H, then search for pre, insert God, frustration. Okay, let's look at the tab HH. Let's look at the HTML mod source code. This is my HTML mod source code. Oh, pop out source code there. Oh, that's why it got repeated, overridden. That's why. That's bad. So this pop out, I wanted to. Okay, so insert. Let's say insert is I. So evaluate this. Okay, then go to Xah emacs key binding, customize, evaluate it, close. Okay, now close, reopen, so that reloads the Xah HTML mod. Now tab tab HH, okay, pcase. Now pcase, yeah. So let's look. Hello, error. Hello, simple. Hello, dose. Hello, simple. You have switched from Firefox to Brave. What idiotic question? Is that trolling? Because I answered that 1,000 times. Firefox, Brave, okay? If you are trolling, I don't know if you are or not, or if you are new here, probably new. But because I talked about that, like, why do you use multiple browsers? Which browser do you use? There's a dedicated talk show like a few months ago, and before that, and before that. Okay, pcase. So study. So I'm just gonna do my job, okay? Which this is what I need to do. Study a pcase. Okay, let's focus on that. So this is pcase. So ML style pattern matching. That means ML means meta language. One of the first functional programming language. ML stand for meta language back in 1970s, I think. So to do, okay, you got a bunch of to do. I don't care. I want to know how to use. Well, the first version was written before I knew about Racket's match construct. The second version was significantly influenced by it. Okay, so a good presentation of the underlying ideas can be found at extensible pattern matching in an extensible language. Oh, this is actually an academic paper, 2010, by Sam Tobin. Extensible pattern matching in an extensible language, okay? Pattern matching is a widely used technique in functional programming languages, especially in those meta-language and Haskell traditions where it is at core of the semantics, true, and Wolfram language, of course. Wolfram language is the granddaddy. Well, I wouldn't say granddaddy, but it's the most powerful than Haskell meta language, because Wolfram language is symbolic pattern matching. Those Haskell and meta language ML pattern matching, or F# or Camel, their pattern matching is structural but not symbolic. Okay, so Wolfram language pattern matching is like Lisp macros, but 100 times more powerful, elaborate. So the language in Lisp tradition, in contrast, pattern matching, it typically provides by libraries built with macros. Okay, we present match, a sophisticated pattern matcher for Racket, implemented as language extension using macros. Okay, this macro really sucks. The syntax, the system supports novel and widely used pattern matching forms and is itself extensible. The extensibility of match is implemented via a general technique for creating extensible language extensions. Okay, I'm not quite sure what it means technically about extension. What do you mean by language extension? Because you just add a function via macro or whatever it means. So, but what exactly you mean extension? How is it different? Just unless you mean syntactical, adding syntaxes, which most language cannot do, even these macros. Let me dispel one myth about Lisp macros. The Lisp phonetics, they will say, Lisp macros allow you to change syntax. Actually, no, not at all. Lisp macros, with whatever Lisp macros, your syntax is still nested paren, always, okay? Then some Lisp phonetics, they will say, especially common Lisp, they will say, oh, Lisp reader macro allows you to change syntax. Not really. You still basically stuck with the nested paren, except maybe you can add this, backtick a little bit, like a little trick, but you cannot create like 1 + 1 × 3 syntax like that, infix syntax. So this macros or Lisp reader macros, they are kind of a historical quirk. Okay, they don't actually change any syntax. However, they do the nested paren transformation. That's what they do. They transform, for example, this, paren, something paren, you can transform it to call other functions, or, that's what it does, macro and stuff. You can hold evaluation, then check what's the argument, then depends on what's the argument, then you do something, such as in a if expression or while loop. You need to check, you need to hold evaluation first. Then in while loop, you change variable in each iteration, things like that. But your syntax is still nested paren, okay? Lisp people, phonetics, these idiots, they insist. This is a giant, huge myth for 30 years, still today. They insist these macros can change syntax. No, not really. It's still nested paren. You stuck with it. Okay. So we got this paper. Let's save it. Cornell University. Okay. I want to make a screenshot. And then read it later. Okay, I will be reading it. Let's download. Okay, view PDF. Okay, let's see how many pages is this. This academic paper, which I read like eating bread. And I find the academics very annoying usually. Okay, this paper is pretty short. Okay, they are basically, it's focused on the scheme Lisp language, also known as Racket. Well, I mean, one version of it. So it's writing a Racket extension. Now, is this match part of Racket already? I suppose this is 2010. The extending pattern matching, the following Racket program finds the magnitude of a complex number, okay, represented in either Cartesian or polar form as a 3-element list using the first elements as a type tag. Okay. So let's save this. So I'm gonna read it later. Okay, close. Wait. Reopen. Back. Copy the URL. back to talk show. Let's paste the URL here. I changed my key, so now it's all new. Copy. Let me show you this fantastic command. Okay, so submit it. I don't care. Let's put the date here by this guy. Title, URL, title, author, date. Press a key, it becomes citation, bibliography, academic citation. Make a list, delete this part, show in browser. Fantastic, beautiful, extensible pattern matching. Okay, let's focus. Let's get back to, so, okay, there's that paper, then what else? Okay, so it's somewhat based on this paper, okay? So now notice there is no documentation. What the fuck? You know, implementation is your problem. How to use this library is my problem. Documentation of how to use this library is your problem. But you didn't do it. That's what annoys me. So let's check Control-H-I to go to the info documentation index. Let's see, search for pcase list matching lines, none. Okay, so yeah, okay, so let's search for, let's call emacs lisp index search. Okay, let's call that pcase search. There it is, the pcase macro. Okay, so it is in emacs lisp manual. So this is what you need to read. Okay, now press a key to show this page in browser. This is fantastic Xah extension, Xah view emacs manual in browser. Okay, so now you see, makes a giant difference. A lot Emacs fanatics, they just like to read this text, plain text version, but the browser is much more beautiful and easier to read because you got all this formatting and bold and coloring. Okay, so you got a macro pcase expression. This is what I need to do. Okay, so any comments? None. So pcase expression, pcase expression rest clauses. So pcase, each clause in clauses has the form pattern body form. Okay, so evaluate expression to determine its value. Eval, expand, eval, find the first clause in clauses, okay, whose pattern matches expand, eval, and pass control to that clause. Okay, so pcase is like a conditional case statement. Okay, if there is a match, the value of pcase is the value of the last body of body forms in the successful clause. That's right. Otherwise, pcase evaluates to nil. Okay, I understand. Do you understand that? Yes, already. So close that. Go back to talk show. Close this and show in browser. And let's start to this is a macro. Okay, I mean this is a manual. There it is. Link to the manual, and let's start to, I know how to use it already. Okay, so I need, you see right now I'm using Xah Emacs mod, so everything I do is like Xah mod. Okay, Xah HTML mod, but here is Xah emacs lisp mod. Go to the source code, go to the directory, delete the backup, delete, yes. So you see this all my, basically all the packages I use today is all just my packages, because I've been coding emacs lisp for 15 years, 20 years almost. So this is Xah emacs lisp mod. So first thing to do is I want a template. I want, for example, D space become different, space become the full template. I want a template for pcase. Right now this got nothing. So let's do it. Let's create it. So template, you go here. So search for, first of all, search for pcase. There it is. Okay, pcase. So pcase and pcase diff macro. Okay, pcase is there. That's part of the keyword, but we don't have macro. So let's add a macro. Okay. Okay. So go down. Where is it? Here. Okay. So psopq. So let's see. Push and a quote. Okay, so let's do a pcase abbreviation. Wait, what? Now, what is the documentation for pcase? That, okay? So actually, so you just pcase expression, then rest cases. Okay. Now rest is split the window, search for comma. Rest is done as a comma. So okay, let's just add a comma instead. So pcase. So now let's alphabetize it. So okay, there, search for pcase. Okay, O and P right there. Evaluate the buffer. You can see run current file or eval buffer. Go to directory, byte compare it. Is there an error? No. Okay, open it, delete it, close. Now back here. Now close it and reopen it. Okay, now pcase, enter. Oh, fantastic. Okay, expression, let's say 3. Now cases, okay, so we need to modify, because pcase you always need, it's always gonna need cases. So let's, even though it's optional, but you're gonna always need cases. Pattern and so clauses. So how does it work? Clauses, pattern. Each clause is pattern in body forms. So in fact, so for example, let's say 4, then 4. Okay, 3, then 3. Let's see if that works. Evaluate it. Seems to work. You see, it returns 3 because 3 matches 3 here. Then run this. Okay, so we can actually make this not messages. Okay, got 3. And here got 4. Okay, evaluated, got 3. Perfect. So this is how you use pcase. Now let's fix the template. Okay, so this case is gonna be, it's always gonna be Okay, let's fix the template. So I'm doing multitasking. I'm doing learning about pcase, meanwhile creating a template for it in Xah emacs lisp mod. Okay, so that's that. Okay, so this x is not date, cursor. Okay, so and new line, any new line encoded by /n. Do it. Okay, and then we got this space. Okay, leave it. Okay, so this is our new pcase template. Eval it, go back here, close it, save it, close, reopen, so that the emacs lisp mod is reloaded, Xah emacs mod. So now let's try again. pcase space, beautiful. Okay, so we got that. Okay, so now I know how to use pcase. You got several arguments for different patterns. Now, but we haven't got to patterns because right now it's literal. It's like matching literal expression. There's no pattern involved. So then it's just like conditional. Nothing special. So we need to learn about what is this pattern. For example, we got some x and we want, some of them is like a string. Let's say is t. Then you return string. So for example, right? So you want to, if this x is a string, you want to be able to match a string. So how do you do that? Not just match t exactly, but you want to match if that's a string. So each pattern has to be a pcase pattern, okay, which can use either one of the core patterns defined below or one of the patterns defined via pcase define macro. Okay, so you can extend your patterns syntax that by using pcase def macro. I see. So that's what it is. So there's a documentation extending pcase. Okay, go back. Okay, so let's check out the patterns. The rest of this section describe different forms of core patterns, presents some examples, and concludes with important caveats, warnings on using the let binding facility provided by some pattern forms. Okay, so pcase can be used in let binding. Okay, a core pattern can have the following forms. Okay, am I doing good? It's like one person watching, is that right? Four people. Okay, continue with the pcase. Okay, so let's remove that. Yeah, so pcase, so pattern. Okay, so now I need to write a tutorial for this. Okay, this page is example advantage over CL case. Fuck common lisp. Here's an example that highlights some advantages a pcase has over CL case. Fuck common lisp. Okay, so this documentation is, it's a few pages. Okay, so let's make it larger a bit. So I am going to read this offline. because I'm meticulous reader. Technical documentation, geeking, that's what I do. Been doing that for all my life. I've read more documentation than all of you combined, including the Lisp phonetics. Okay, so let's see. So you got some patterns. So let's look at the patterns. Underscore matches any expression. Okay. Okay. Underscore is like don't care, wild card. This is like the last, condition. Like nothing matches, then just use this. Quote var matches equals to var. Comparison is done by eval equality. Okay, so quote val, does that usually mean symbols? Usually matches equals val. Wait, but if it's a number, you don't need to quote it. So what would, so there's a question here, because usually when you quote symbols. So does this mean this quote, this val can also be a list? We can test it. So for example, so cut, let's see. Let's say it's a, so this expression can be a list, okay? 3, 4. Then let's say one of the condition is quote 3, 4. Then message got list, okay? Say message got 4. Okay, so let's eval this. Let's see. There it is. I was correct. So you can like, you can yeah, so but I still don't fully understand. Okay, anyway, let's move on. So there is an underscore. So if underscore means nothing matches, okay? Okay, so underscore. Interesting. So you see, this underscore is beginning to be a real pattern, because that's not a valid Lisp syntax, because underscore is undefined. So now okay, let's see what okay, got list. Okay, so but now if we try, let's say 9, there it is, because nothing matches. Now let's see if the order matters. Okay, so copy, and let's say 4, but you put the underscore at the top. Okay, will it just match this one? Like, do they go by order? I suppose. Okay, so let's try it. There it is. Okay, so yeah, so this shows okay, pattern match in order. Okay, so next, so we got keyword integer string What does it mean? Keyword integer string. Match if eval equals to the literal object. Okay. The special case of val. Okay. Self-quoting. Okay. Now what is this? What is this keyword? Control HI. Well, we gotta search. What? Pcase. Okay, so what is that? Okay, so keyword integer string. They basically, this is bad formatting from GNU Emacs, this manual. Well, okay. Because it's semantically, logically kind of inconsistent. Anyway, so keyword integer string, so all these are literal values. Okay, so keyword, does that mean it's a symbol? I don't know. Okay, so let's see. Symbol match any value, and additionally let bind symbol to expand eval. Such that this binding is available to body forms. Okay. If symbol is part of sequence pattern. Oh God, this. Okay, so all these patterns, they can get complex. So you got a mini pattern language here. Oh, then you have AND patterns, where a pattern must match all these patterns, an expression must match all these patterns. Then you have all patterns, which means an expression match any of these patterns. And you have Rx. Okay, so matches string against the rejects Rx expression using Rx notation. Okay. So this pattern is for matching. This pattern is basically regular expression for matching string. However, using the Lisp regular expression syntax in the Rx package, okay, called structured rejects notation. Okay, but anyhow, it's still just matching strings. Okay, so you got AND, or you got let. So this let is a pattern. Evaluate expression to get and matches. God, evaluate expression to get that, and matches if expression var matches pattern. Okay, what does this mean? Evaluate expression. It is called let because pattern can bind symbols. Okay, I don't understand. Now this guard is basically a condition. Guard matches if Boolean expression evaluates to true. So this pattern basically here is a function. So basically this allows you to use a function that returns true and false to determine whether it match or not. So instead of using a pattern, you use a function. That's what it is. Okay, so this app function pattern matches if function called on the expression returns a value. Okay. Okay, so yeah, so okay, so this gets a bit complex to actually test out each one. Yeah, it can get complex. So what we do now, am I doing good? 9 people watching. Rudolph and MBJ. Okay, so what we do today, I mean, what do I do to make it useful for you guys? Because this pcase, you'll need few hours, and I'm going to write a tutorial for it. In fact, I can start to write a tutorial. Yeah. So you see, we got some examples of pcase pattern matching. I will be writing a tutorial of a complete tutorial, and with lots of examples. But the question is, what do I do now? So let's have an overall look at this page. Okay, so here it covers different patterns. Now, what is QPAT? A backward style pattern. Okay, so you got backward style pattern, so it is a bit complicated. Okay, so you got patterns, so symbol, backward style pattern, CL type. Okay, matches if eval expression eval is of type, okay, which is a type descriptor as accepted by CL type P, type predicate in Common Lisp extensions. Fuck Common Lisp. Okay, so it's got, type predicate. Yeah, I really don't like the Common Lisp thing. And predicate function matches predicate function return nil. Okay, so you got these patterns. Okay, a function call with n arguments. Okay, so all these are patterns. Okay, it would take few days actually to write a full tutorial. Now, example, advantage over CL case. Okay, example using AND. Okay, so combining patterns. Example, reformulation with pcase. What does that mean? Here is an example that shows how to reformulate a simple matching task from its traditional implementation to one using pcase. Okay, now what is a guoc? The doc string. Oh, so there is. Okay. So guoc is something it defines here. So if object is string, okay, so yeah, so basically this example is saying that, if you are not using pcase and if you want to do string match, then this is what you write. So he's showing you how, if you are using pcase, then you can make it something. You can make it simpler, I suppose. You see, fairly complicated. Okay, yeah, so this is gonna be fairly complicated. Side affecting code referencing symbol is undefined. Avoid. For example, here are two similar functions, both use AND, symbol, and God. Okay. So what is this section? This section is caveats, so warning. Okay. It's on and on. Okay, so that's an overview of this page. Now let's go. So what is this? The pcase macro. Let's go up. Chapter section 11.4 pattern matching conditional. Okay. So aside from our basic conditional forms, Emacs Lisp also has a pattern matching conditional form, pcase macro, a hybrid of conditional and CL case. See conditionals in common Lisp extensions. Okay, so it goes to, common Lisp has its own documentation outside of Emacs Lisp manual. Okay, I don't want it. Okay, go back. Okay, so you got pcase and CL case that overcomes their limitations and introduces the pattern matching programming style. Okay, the limitations that pcase overcomes are something. Conceptually, the pcase macro borrows the first arc focus of CL case and the clause processing flow of conditional, okay? Replacing condition with a generalization of the equality test, that's right, which is a variant of pattern matching, okay? Yeah, because equality test is basically a pattern matching of testing literal expressions, okay? That is pattern matching with no patterns at all. Then that is equality test, the typical, equal or something. And adding facilities so that you can concisely express a clause predicate, okay, and arrange to share let bindings between. Okay. The concise expression of a predicate is known as a pattern. When the predicate called on the value of the first arg returns the nil, we say that the pattern matches the value. Okay, so when it matches, we say it matches. Okay, so the pcase macro we looked at, extending pcase, which is extending the pattern syntax, we don't care. Backquote style patterns, that's more complicated. This is very fairly complicated part of Emacs Lisp and Common Lisp. Then destructuring with pcase patterns. Okay, so now I have an overview. We have had an overview of this pcase documentation. Okay, now the last part is interesting, destructuring with pcase. So it adds a function, it adds pcase let, and pcase let star, pcase do list, pcase set q, pcase lambda. Okay. Okay, so I have a good overview now. I know what this library do, and my initial feeling is that right now is don't use it. I'm not gonna use it. Never gonna use it. Why? Because this is pattern matching. Okay, pattern matching is fairly advanced feature in functional programming languages. Okay, so for functional programming languages, typically they are built in, such as meta language, Wolfram language, Haskell, OCaml, F#. Those are derivatives of ML, meta language. They are built in. That is, they are not an extra library. They are designed as part of the programming language. Okay, part of the programming language. In fact, they are the core part of the programming language. So when you are talking about F#, OCaml, Haskell, ML, the pattern matching is part of the core foundation of the programming language. Okay, they are not something like let's write a library and add it. Okay, so that's important. That's critical. because this pattern matching is fairly, if you're gonna implement it, it's not trivial, okay? And there's a lot cases, theoretical issues, just like regular expression. Okay, so like regular expression is for string matching. For majority of languages, it's built in like core library. Well, I mean, anyway, so when you add a pattern matching, like in the emacs lisp case, as a language extension, as a library, like right now we have, this pcase library, 1,000 lines of code. That makes it, that makes it slow, and I mean relatively slow, and makes it kind of fickle and a bit complicated. So right now my feeling is that I'm not gonna use it, because you are essentially learning. If you want to use this pcase, you are learning a mini language for the patterns that's not native to emacs lisp nor common lisp. Okay, so, and I'm presuming the implementation is fairly involved. I mean, even just learning how to use it is fairly involved. You got this. So the implementation would be fairly involved. Let's see. Okay, let's see what define they have. Okay, so you got this dash dash means it's internal function. If the function name contain dash dash, it's like internal. Okay, so you got this. Oh, so it's like almost all of them are internal functions define. Okay, so you can see they are relying on these internal functions to work. Now, let's see define macros. Okay, so these are the exported functions, these macros: pcase, exhaustive, pcase lambda, pcase let. Yeah, okay, so I guess we know. We know what this package is for. Yeah, do we want to use it? I don't know. I don't know. I'm not sure. And I'm not even sure I want to write a tutorial for this, because to write a tutorial for this will take several days, 3 or a week, full time. And for that time, I'd rather be writing a tutorial for F# language or Ling. Okay, so I think that's it for today. Hello, big fan Joy. Where is the tequila? No tequila today. Today is coffee. Okay, I think I'm done today. We learned what does pcase do, and what is the use. Well, I mean, there's some use. For example, I can pattern match and find out which is a string. But in general, in emacs lisp, the use is not very common. Yeah, so, and the code is fairly complicated. Okay, bye guys. if you like my stuff, pay me. Okay, go to xahli.info, all the way down. Pay me $100. Amazon, PayPal. Bye. Okay, let's put it back. Show in browser. That's what we did. Okay. Bye, guys.